All right, lesson 2. It's a good song of the day.
It's not Friday yet, though.
Yeah.
Yeah, that's.
That nightmare.
But aren't you looking forward to Friday?
I can't wait until tomorrow, where the song of the day is also Friday.
It's just like 2 songs. Okay, that'd be rough. Okay, let's see.
Wasn't that song horrible, or is that was just me?
Yeah, it was always really bad. But yeah, so some rewind. I'm just gonna check my. Okay, yeah, I'm recording. This is good. So yeah, we talked about PBR. I remember Scott had a question about PBR, so I included this just to show what all the layers can look like on a material. So I guess the big concept with PBR was to strip everything even more than before and then move all of the information into different layers. Because I think before you would get shading information in your base color map, which is the one on the left right here. And of the second, it should actually just be sorry, like for the slides, it should be in the same thing. So what I do is I just keep adding to it. So if you refresh it, it'll be updated.
Sounds good.
Yeah. So yeah, you can see the normal information. There's just very, very tiny amounts of shifting because on a floor, a floor is not really moving that much. It's pretty subtle. And then the black map, my guess. Oh, that's a tough one. What do we think the black map is?
I'd probably crack that code.
Because I'm gonna say that this is usually like roughness is the gray looking one. I'm gonna assume the one beside it is AO.
I'm gonna guess metallic.
That's what I thought too. Yeah, I think this is like one of those. I guess it would be called bitmapped material, where it just makes all the maps regardless of if it makes sense. Because like on a floor, you probably don't need a metallic map unless there's nails, I guess. Yeah, I think you're right. Yeah, that's definitely what that'd be. Cool. So, any questions about PBR before we move on, or
Not for me, anyways.
no? Okay.
I think I'm good.
And you guys know what it means, like the acronym?
Photo-based
Rendering?
Yeah, perfect. Nice, good job. This is that Z fighting thing, remember? It sounded awesome, but it's gross.
What the hell is that?
Someone wants to say why it's so bad?
Well, why it's really bad?
Or what's happening, yeah, like if we can take a stab at what's going on.
Fighting on the Z-axis, I'm gonna say.
Yeah, I think that's why they call it Z fighting most of the time, because typically it usually occurs on the Z-axis. But if you look on the left and the right, no, I mean on the right, sorry, what am I talking about? The shampoo bottles and stuff, that's like every axis. So it just means that it's occupying the same coordinate space. There's two things. Typically you don't see it this bad, but they colored it like one color and the other one's another color. So that just means you have 2 planes or 2 objects in the exact same position. So the one on the left is classic Z fighting, and that's where it got the name, because it's got, yeah, you're right, it usually is a Z thing.
Okay.
But it can happen like this. And sometimes it'll be modeling. The reason why I bring this up, you might duplicate something you don't know, and this will occur. Or if you're trying to intersect objects and you do it a little bit wrong, this can happen. So like in the future we're going to be talking about intersecting, but we just want to make sure that we're doing it right so we don't get this error. And there's other times where you should definitely try to connect your geometry so you're not having what would be considered loose geometry or separate objects joined together. Yeah. Okay, so remember back in the first lesson we talked about angons, poles, quads, tris. What is a pole? Let's just take a stab at it before we get to it.
it looks like they're kind of compressing to one. Not, I would say like, is it one vertex?
Yeah. It's this is kind of it shows what can happen when you subdivide it. So this picture is actually not great. I might try to find one on Google for you right now.
Is it a z-axis issue?
Well, no, poles are it's just topology, right? Yeah. So, okay, this is a perfect example of a pole. It means that you have things joining, in like a large amount of things joining into one area. So typically, n-gons can create poles. I think it's when you have over 4. So like right here, see where my mouse is? That would be like a pole. You have 1,
Okay.
2, 3, 4, 5. It's just kind of like when.
Over the counter.
Yeah, and essentially what'll happen is if you use subdivision modifiers or things like that, a pole is kind of like you can imagine it like an intersection, right? So here they're going and it's like, sweet, we know the direction. There's a flow. That's the edge flow is going. And then it reaches here and it's like, man, I got a lot of roads I can take. I don't know which one. So it's going to stop. And that's kind of where a pole can be annoying. They can also do, I'm going to move this. They can also do this when you subdivide them because poles aren't even. Anyways, so good to think about.
Okay.
Typically, if we're hard modeling, you shouldn't really have that issue because there will be times where you need poles. It just is. And then the one on the right I thought was kind of a cool example of some horrible mess. I guess the issue being here is that you have an internal face where it shouldn't be, and then this right here, this n-gon on the top is see-through, so you can actually see through the geometry. The reason why it's see-through is that the normal is flipped. So the normals are all messed up on this little model. So what you could do is you could recalculate it. And this is a different program, but same thing kind of. So in Blender, there's all kinds of cleanup things that we'll be learning, and that's called like recalculate normals. So you remember if we go back to early, what a normal is and all that. Like, do you want me to go back real quick? I'm gonna do that.
Okay.
Yes. Okay. Here you go. These are normals. These little red lines. That's what it should be doing. It should be facing out, and in this situation, it's all messed up. So you have one facing flipped, it's inverted is what it would be called, and then the other ones are facing out. And then you have an internal face. So typically you don't want internal faces because you're never going to see it. The game engine or whatever engine you're using will have to calculate it inside the object, and it's just wasting resources and kind of adding errors. So yeah, that's kind of a good thing. So here is another example of normals that are bad and very, very, very confused. This could also be, no, in this situation it's not really a light map example because it's in the editor. It's just bad normals. And then if you notice, there's some areas that are smooth, like see the windshield? That would be with smoothing groups turned on. And then the rest doesn't have smoothing groups on because you can see the hard edges, right? And then you have little black spots and things that are messed up normals. So essentially, because it's facing not the direction that it should be, it's trying to render it as if it's like in a shadowy, weird area. So if you ever get that, that's a sign you need to recalculate your normals.
Okay.
Yeah. So then n-gons, we talked about that before. They can get gross, of course, and a main contributor to n-gons, in my opinion, is booleans. We're going to talk about like why booleans are great and why they're absolutely horrible sometimes. And there's kind of like, I remember in James's class it said don't use booleans, and then nowadays and stuff, like there's definitely some times where booleans are kind of the best way to go about something. You just have to be very careful. Here's a great example of some messed up shading you can get from an n-gon. You can fix this by just providing more information. That's usually the number one issue with the n-gons, is they just don't know what to do. It's like, you need to tell me how to shade this. So you just got to give it information. It'll be happy when you do. So this was done with a Boolean operation. See these little windows? You'll see on the right, it's super crisp, very, very clean. And on the left, it is disgusting. And you can see it tried to triangulate it, it made some n-gons, it did some weird things. However, for the type of model I was making, I kind of just wanted to Boolean it because it's way easier than figuring out how to make this kind of even circly looking thing in there. So that's an example of where you'd want to use a Boolean, but at the same time you don't want that disaster on the left. So we can do a thing called data transfer to fix it. And what I'll do is I'll draw a quick little diagram of what a data transfer is, because it's kind of cool and it should help us kind of get a bit of a grasp on Booleans. Okay, so lesson 2. Okay, so you have an object like this, and then these arrows represent the direction of the normals, right? When you do a Boolean, you're going to cut into it or add it or something like that, right? So what is happening is when you cut into it, it gets a little bit confused about these areas, and it kind of makes up, it tries to figure out what's going on. It just doesn't know. So you can see the arrows are kind of like all directions. So the idea of a data transfer is that you say, remember this, okay, keep this the way it is, and then on the other object that you're trying to add, you say, okay, now keep this. So essentially what we're going to do is when we merge them, we'll have to stash this object, which means we're going to remember that object as it was before we tried to mess with it, and then the other object, we're going to remember how the inside is. So you have to do a little bit of work ahead of time. It sounds kind of weird right now, but when we get into it, it'll make more sense. So you got, yeah, and basically by remembering what the objects look like before you did the operation, you'll get the effect on the right. So you can actually get away with some weird stuff if you're doing things properly. So it's kind of cool. So Boolean, what is it? What's I kind of talked about it a bit, but you guys want to take a stab at it before we get into it?
Cropping and merging objects together? That's what it looks like.
Yeah, it's pretty close. So essentially, Boolean means we have two objects. We're going to take information from one of them to affect the other one. So we can either add it, subtract it, union them. So right here, you see you start off with a cylinder and a donut. And then you're saying, okay, remove the donut from the cylinder. So it chops out this piece. In the one on the bottom left, we're saying take the, which looks like a donut but low poly, but take this shape out of this one, and that's what that is. Most of the time, subtraction, which is what these operations are on the left, is kind of like, in my opinion, the most useful. Other times you'll find union is also quite useful as well, which is on the bottom. Intersection is okay sometimes. The issue with Booleans is that the topology doesn't connect. It usually has a hard time figuring out what to do with the topology. So you're kind of left with a very permanent result when you do a Boolean. There's things like box cutter, you know, and it kind of does a better job figuring out the topology, and there's some Boolean operations that work better. But this is something that we'll be using later on, and it gets us shapes that you just can't do very well otherwise. So it's quite handy. Any questions?
No, it's pretty straightforward, I think.
Okay, perfect.
Yeah, ditto.
Okay. So this is kind of like opposite of a Boolean, I guess, but it's kind of like it because if you're planning on doing what's say you look at union, right? If you plan on doing that, you could also do intersecting objects. Now, if you do it wrong, you get this, which is gross. But if you do it right, it should be okay. There will technically be it's called a collision. When you import it, it'll be like there's a collision here. Some renderers are more okay with it than other ones. You just have to be aware of that, I guess. But there's times where you really have to intersect, especially when you're dealing with potentially rigging things or whatever, and maybe you want the object to be able to rotate and still have the information, and you don't want to bend it. Anyways, we'll talk about that later. In this situation, they just made this object by connecting everything and doing it all in one shape. That is a disgusting amount of polys, so I'm assuming it's meant for like a render. On the left, the polys don't really match. Everything's kind of weird, but it can be done, and it can be quite helpful. So we're good with that, right? I guess it's basically just moving an object through another object, and the best situation is when it's perpendicular as it can be. So if it's 90 degrees into it and the other object is not, when you get Z fighting is when they're not intersecting at a very drastic angle, because they're perfect, right? Like right now they're exactly flat facing the same direction. You don't see that here because it's just cutting through it in a way. So because of that, it's a lot better than classic Z fighting, I guess. So there's two types of modeling. The one that we're going to focus on is hard modeling. Then there is soft modeling or sculpting, and that would be what's on the left. So I don't know if you guys can quite see the topology enough on the right. Can you guys see that?
I can see it pretty
I can see it, yeah.
Yeah?
Yeah.
Okay, perfect. So let's talk about some of the advantages of hard modeling over soft modeling. What do you guys think would be some big advantages this way?
Yeah, no, I think it just depends on like your use. Do you want to go into something more organic looking? Sculpting is probably the way to go, just because it's much like working with clay or something.
Yeah, absolutely.
Hard modeling, of course, or hard surfaces, stuff like that.
Yeah.
It seems like you're less prone for topology issues with hard modeling.
Yeah,
I
actually.
mean, if you bring two images there.
Definitely. In some cases, if you're doing hard modeling properly, you have exact control. So if you do it well, you shouldn't have a lot of issues where sometimes you're at the mercy of the program that's kind of like sometimes in ZBrush it's called Dino Topo, in Blender it's called
Also Dino Topo.
Dino Topo. Yeah. I was like, wait, they're the same. Anyways, so basically
Dynamic topology.
Yeah, dynamic topology. It's always rethinking the topology based off of what you're trying to do, which is really great, but sometimes it screws up. On the right, I would say there's a couple advantages. We can cut the polys down a huge amount, so it can be a lot cleaner, less polys, definitely sharper edges, like you guys were kind of saying. You get exactly what you want, and you just have a ton of control when you're hard modeling. Where if you're trying to make human or some sort of animal, anything that's living usually works really well with sculpting. The issue with sculpting is that it's usually super high res, so you have to retopologize it, meaning you use the high resolution model, and then you project a new mesh over it that is less resolution. You do that thing that we are talking about yesterday where you bake the information into the normal map, and then there you go. So it works pretty good. the precision you get with hard modeling is amazing, and you can't do things like modular modeling. I'm gonna write that down actually because I gotta talk about that later. Okay, so modular modeling is based off of extreme precision, and then so the idea is that you can click things around and have it attached, so you can kind of essentially make Lego, but digital, right? So you can. It's really really good for making scenes where you can have it scalable quite quickly. You don't have to keep redoing everything, and then that's also working with the grid a lot. But to make it work, you have to tell things to be exactly in the right spot. You have to say, I want this face to be lined up with this axis at this amount, right? So just kind of something to consider. But yeah, we'll focus on hard modeling, and honestly, there's a much bigger demand for hard modeling than soft modeling most of the time. Especially when you look at like photorealistic stuff like architectural visualization or any of that. It's almost always hard modeling. So, destructive versus non-destructive. You'll see if you go through some tutorials, non-destructive stuff like this called Nitrox 3D. It's actually like a weird acronym for modeling in a way that keeps your models non-destructive. However, it's kind of working in a workflow that's all about modifiers, meaning there's certain things you can do, like a Boolean operation is a modifier. You just stack a whole bunch of modifiers on top of each other and try to get as far as you can. So like if you see this, these edges have a little bit of softness to them and they kind of catch the light. That's done with a bevel modifier, which means it kind of rounds the corners. So there's a bunch of stuff going on, a ton of Boolean operations, and it keeps it so that it's less destructive. In my opinion, it can be actually kind of limiting sometimes to try to think about modeling this way, because it works for shapes like this, but if you don't have shapes like that, it can be really tough, and you can be fighting with the modifiers. You can be you sometimes you get a ton of errors this way, and it's a nightmare. It's usually pretty advanced. So I'd say for right now, we'll kind of keep away from it. We will touch some of this stuff, but yeah, when people say non-destructive, really everything in 3D is always kind of destructive. It just is. So that's why we really have to think start to finish before we even start. Kind of visualize how the modeling is going to work in our head, and as we go, we'll get better at that. But it really comes down to like using the right shapes to start with, doing this to start with, and all these certain things in the right order. It'll really go very far. Yeah. I love the image on the left. It makes me laugh every time. It's like Tomb Raider or something. So yeah, Scott, here you go. We got some UVs. I'm probably gonna elaborate on this more a later date, but for right now, actually, I'm kind of curious what you guys think. What do we think about UVs? What do you guys think is going on here?
I mean, it's to map where it's kind of like it's like taking your mesh and laying it out flat, but doing it in a way so that it's all attached and like it's cut well. I don't know like an exact boy, but yes.
Yeah, I'd say that's a pretty good way to put it. It's usually like it gets pretty weird with UVing because it's very close to like skinning an animal, especially with people. So like you get creepy UVs like on the left, but essentially a computer doesn't know how to map an image onto a 3D object because it can't think in a 3D image. Do you know what I mean? It can only work with a 2D image. So what it does is this, like right here on the left or on the right, this little island, is usually placed onto UV coordinate space, and then from there it allows it so that if you put an image on that, it's usually a standard square space. It'll map whatever is on that image. So if you have texture here, it'll basically project it onto that area of the leg. And then if you have, say you painted a foot here, it should map it to there. So it basically says this pixel is projected there. So yeah, UV mapping is going to be like super duper important for getting good textures, good light maps. We'll talk about that in a second. So the edge here, if we look at it, this is called a seam. It's where we tell it to be cut. And typically seams are noticeable because things might be facing in the wrong direction, because based off of how we have the this is called an island rotated, it's going to basically rotate it in a certain way, right? Like it'll appear differently. Then there's also wrapping, margins, and packing. So if I find a better image of a light map, I'm just going to do that in a second. Sorry, not a light map. Just so you can see a better example of what a UV island should look like, and they can get kind of crazy. So the program we're going to be using for UV unwrapping it's an add-on called UV Packmaster Pro. And the cool thing about that is I kind of like to think of it like Doctor Strange in the second last Avengers movie, where he thinks of every possible outcome and then he's like, this is the best one. That's basically what this does. Okay, so I got the image. So this is a pretty decent UV workspace, and these are all the islands of a thing I made. You can see you don't really want them to be touching. So like here, you can see we actually have an intersecting object, so that was an error. I had to fix that later. But for the most part, it does a pretty good job. If we compare this to the standard Blender, I'll show you why we want to use... Yeah, you guys can see that, right?
Yeah.
Yeah. So standard Blender does a terrible job. And it's not just standard Blender, this is like every 3D program. So the way James describes UVing is actually, it's a pretty good way to explain it. It's like sewing. If you're trying to make pants, you start off with something that looks like this, and then you connect it together at the seams, and then you'll have a 3D object. But the funny thing about UVing is it's the opposite of sewing. You're kind of like ripping it apart into the islands. And then it'll kind of like wrap and then turn into a shape. Have you guys ever made those cubes? Paper
cube?
Yeah, paper cube. Okay, so you know this like from school. You basically cut out the edges, you fold it in certain spots, and it turns into a piece of, it looks like it should. You can imagine UV wrapping is pretty much the same as this, right? So the idea is that it basically takes this stuff and then puts it back onto the model that you made. So yeah, do we have questions so far about this? It's kind of a weird thing to explain.
Sorry, could you repeat that last sentence? I just didn't catch something about putting them back on the model.
Oh yeah. So what it does is it has all of these islands and stuff, so it has the information. It'll be a texture information, which is just an image. So an image will go over top of this. In fact, let me just actually bring up some of those images, because I got a couple, and it's kind of cool if you see it working live. And I'll also open up Substance Painter too, because Substance Painter, you're working directly with the UVs. And I think if I show you guys it actually working and moving and stuff, is kind of a better way of doing that. Okay.
And this program is the most effective way to paint UVs?
Yeah, Substance Painter is amazing because you actually paint it on the 3D object and not on the UVs. So
Oh, cool.
what we're looking at here is the image that goes on top of the UVs. Substance Painter is very heavy. I've also been painting with 4K maps, which are really, really big. But the idea is that to get a texture on this guy, we need UVs. If you don't have UVs, you just can't put a texture on it. At the end of the day, that is how it works. You can see, based off of the one we're looking at, these are the UVs and the information for that. Yeah, so when we do Substance Painter, we're going to work in smaller image files. 4K is hard on the computer. Very, very tough.
Did you paint every individual piece?
Kind of. The cool thing about Substance Painter is it has like live masks and stuff. So you can get a lot of detail without having to do it all yourself. You don't always want to rely on it because what'll happen is it looks very kind of templatey or default. And it's kind of like any art form, I guess, in the sense that you want to think of like the story behind it, what's going on. You can imagine if you had a chain that's rubbing on something, there's some history there. So you can kind of see these are the islands in the UV space, and it's putting this image onto that part of the model. Yeah, pretty cool.
Cool.
Yeah, that's about it. Yep.
But you said you can paint. Don't exit. You can paint right on the model.
Yes. Don't exit. Yeah, I'll show you.
Ah.
So, if you look here, I'm gonna open up this. There's a paint layer for the gold armor. So if you look at the gold area, you'll see that it comes in and out. So I can actually get a brush. If I hit X like Photoshop, it inverts the color. So just like that,
okay.
you can paint things on. You can use particles, and like we'll be doing like a whole bunch of stuff like this later, but this is to come for sure.
Cool.
Oh my god, that is easier than Photoshop.
Oh, it's so much easier. Check this out. This is crazy. I hope it doesn't crash my computer. It's a particle brush. So, yeah, just like that, I'm projecting particles onto it, and it's actually thinking about how they move. It's lagging a lot because it's freaking 4K.
That's crazy.
Yeah, so it's really cool. I'll go back and do everything. So you can kind of see like I already did some of that work, over here. Yeah, pretty cool. So you can go combined, F2, F1, there you go. So if I paint here, just to show you guys, if I paint on the top here, okay, do you see how we just kind of removed the...
Oh yeah, there you go.
Yeah, you can see it now. So you can actually paint right on a UV, and it'll be mapped onto the 3D thing.
Oh.
What makes it, what I like about this is that it doesn't paint on negative space, which can be quite a bit of like a very big problem, especially when painting textures on UVs. That was my experience with Photoshop, so I'm glad this program exists. My God.
Yeah, it's super useful. And then each channel in here, there's a bunch of different channels. It'll produce. So these are the channels it bakes out. They look super weird, but they work, which is kind of cool. All right. Yeah.
I like that.
Okay, so a seam, like I said, it's the edge of a island. The island is just a piece of the object that's been cut out. The thing I showed a while back there had a ton of islands. This one is only like really one. It's just been cut in two. This one has like 1, 2, 3, 4 more islands, right? Sometimes you'll want a margin between it so that they're not directly touching each other. It just makes for sometimes a cleaner texture. Packing it basically means that it's going to figure out a good way to place it on the UV coordinate space. Yeah.
I've noticed that if you have them touching directly, you can sometimes see the bleed in the seams on your model. So you have just a completely different color outlining your seam, which is the opposite of what you want.
Oh, yeah, that's a really good thing to say, yeah, because that's gross. So you can imagine this guy here, he has the seam on the side of him. You would just see this random strip of color, and that would be really bad. How you guys feeling for UVing? Is this kind of weird, or is it getting less weird?
Oh, it's getting less weird.
Yeah, it's weird.
Okay.
Got it. Pretty, more or less.
Okay, cool.
Oh, yeah.
And like due to the nature of cutting something and flattening it, it's going to have a thing called stretching too. So stretching will occur in areas like the arms or whatever, or the torso here. Basically, you can't ever get a perfect project. Some areas will be squished and some areas won't be, and they'll actually affect the resolution of some of the areas. And on top of that, it makes it so that your textures will be a little bit odd looking in some spots, right? So you have some blurry areas and some really crammed looking spots. So just to think about that. So we want to try to avoid stretching, essentially. So light maps, we don't need to go into it too much. All you need to know is that light maps are made from UV maps. When you bake out something in Unreal Engine, it's going to basically look at your UV map and say, okay, cool, I'll make a version of this. Basically, it's a little bit different. Everything's cut up into more pieces. But if you don't have a good UV map, you'll get light map errors. And this is kind of what it'll look like if you have light map errors. You'll have weird issues where the lighting doesn't look good on an object, and that's because it made a really bad light map. A light map, you can think of it works in the same way a UV does, but it's instead of figuring out how to put an image onto it, it's figuring out how to put the light information onto it. So yeah, that's about it. Everyone good with that?
Yeah.
Cool.
Yeah.
Yep.
Nice.
If you do your UVs correctly, then you don't have to worry about light maps at all, generally.
Yes, absolutely. The first time we made Sad Robot, we didn't UV anything. So we couldn't bake the lighting, and it was a disaster. So definitely UV, and I think we just didn't want to because we were being lazy. However, we know better now. So always UV. Even if you don't have a texture on it, it needs the light map, right? So, and then basically, if we want to put multiple materials on an object, we can use a thing called material groups. That's essentially just saying, for this part of the model, let's make it a different group than this. And then you can get things like on the right here where you have this kind of like sort of rubber looking material, and then there is like a kind of coppery material that would be separate from it. To save on like information, there's a thing called vertex coloring, which is this crazy thing on the left, and Substance Painter, you can import an object without sometimes material groups to basically separate a selection and still put a different looking material on it while keeping it in the same texture. So that's good if you want to save down resolution. I'll kind of explain, I'll just draw it out. Okay, so when you have a UV, you got your object, you have all these little islands, right? So the issue with this is that this is already 4K, right? What's the issue with this? If it's 4K?
It's gonna be really large.
Big.
Yeah, it's heavy. It's heavy as shit. Like you saw like Substance Painter, right? It was like having a hard time because it's doing everything at 4K. Substance Painter does run slow, just so you guys know, because it's creating everything as you go. But it's way better to doing it in Photoshop. But if you use multiple material groups just to separate objects that could be condensed into one, you'll get this issue where you have this, say, as a separate material group, right? And then like another one might look like this.
So the biggest takeaway is that material groupings makes UV unwrappings more memory efficient?
No. Material groups allows you to have multiple materials on an object, which is fantastic. But imagine this is like plastic, right? And then we want this to be metal, okay? And then we want this is like material group 1, material group 2, material group 3. So we can actually tell it to be plastic, metal, and cardboard. So it allows us to put multiple materials on a single object. The downfall with this is that suddenly we have 3 maps that are 4K. So you have 4K, 4K, 4K. Do you see what I mean now?
Yeah.
That sucks. So if we can take these all and then merge them into one, that is the best situation. So it will look like this. Sorry, this is a little bit time consuming, but I really think it's going to help. This is what vertex coloring is doing. Alright, okay. So see, what it does is it's going to do that. There's overlapping UVs right there because I didn't think about it when I was drawing. But normally you wouldn't have that. Do you see that?
Yeah.
So what you want to do is you want to have it all into one so that you can still have plastic, metal, and cardboard, but you'll have like, these ones are cardboard or whatever. You'll have some of it is plastic and some of it is metal. Just so that you don't need to have a million textures that are all 4K, right? You could do one 4K texture, or even better, you could do one 2K texture, or maybe less. But the idea with vertex coloring is that you actually don't need to use a material group. So this super confusing right now, but good to talk about it ahead of time so that when we get there, we've at least heard of it. Because to be honest, like it's a pretty advanced technique. On top of that, you get really huge optimization gains. Most people don't do it, but if you can do it, it's going to be so much better. But the bare minimum is you want to be using material groups, at least, right? If you want those multiple materials on the same object, you have to use material groups, and if you're going to be extra fancy, use vertex coloring.
Okay.
Yeah, does that make sense?
Yeah, I'm writing things down. Yeah.
Okay, sir. What is a computer number?
X and O's, zeros, and I think binary. Never mind.
Yeah, well, I mean, yeah, if you think about it, binary is kind of a part of it. It's the whole reason why they exist. But it's a factor of 2, right? So when anything is done, essentially in the engine or whatever, with a texture, it's usually locked to factors of 2, so like 512, 4096, 8192. So those are different versions of factors of 2. So a computer will run way faster if you have it set to that resolution. There's some examples, like if I go into Sketchbook Pro, image size, that's actually not a perfect computer number. However, if I wanted my Sketchbook Pro to run faster, it should actually be 2048 by 2048. Anyway, so it just has to do less thinking to get there. Those are going to be the most performance. So if you can have an object be set in those numbers, it's always going to be better. Cool. Next thing we got is rigging, bones, pivots, parents, constraints. Essentially, this is just allowing an object to move. If you don't rig an object, it's not going to be able to bend and animate. It's kind of that's how it works. It kind of reflects like how the real body works, I guess. Do you guys want to take a stab at what's going on here with the image?
I mean, is it just setting up bones for animation points or where things can pivot?
Mm-hmm.
Yeah.
Yep, that's perfect. On the left, that's exactly what you're doing. So you're saying pivot in that area, bend in this spot. What we see on the right is it's called weight painting. So to tell it where to bend and what not to bend, we can weight paint it. So I'm assuming the red there says don't bend. And then when you move into the blue, it would be most bendy. And then the transitionary.
It's the other way around.
Oh, is it?
I could be wrong though.
Yeah. When I got this. Oh, it is Blender. Never mind. Anyway, so there's essentially a color for lock and a color for move. We'll have to check out what colors those are. And when it is in that moving color, it tells it to bend, and then the other color will be like, nope, don't bend this. So then there's a thing called IK and FK. So IK is inverse kinematics, and then FK is forward kinematics. So in our school, they teach FK, which is really too bad, because IK, in my opinion, is a lot better, and it allows the game engine to do really cool stuff. I'm gonna open up a YouTube video for you guys. Okay, so if we take a look at this guy, you see how he's like, his hand is perfectly grabbing the door handle.
Mm-hmm.
And then when he goes over here, he reaches up, and it connects perfectly. This is done with inverse kinematics, so that means that it basically figures that it finds the end point of the chain of bones, and it tells it to go there, and then it kind of figures out everything in between. So you can totally make IK adaptable. It's pretty great. Dylan knows a lot about IK. I don't yet. I know a little bit. I just know it's the future. So yeah, he actually touched it. If you look at games where they don't have IK set up, they'll have like floating animations where, you know, they might call or whatever, but it doesn't actually go where it should go. Yeah, you just get like weird stuff with FK. FK is basically moving each bone until you get to the end bone, right? So this looks like a pretty good video. I can probably show you guys. Yeah, do you see that? The little kind of jerky adjustments. So you start with the elbow, then you go to the wrist, and then you tell it to grab the phone. And then, so that's forward. You see how it works? Like you can only do one thing at a time.
Okay.
It's a massive pain in the ass. It takes so much work. Now if you look at inverse kinematics, you just grab what you want and it'll figure it out. You grab the hand and it's like, oh, okay, I got it. IK takes a little bit more work to set up, but as you can find out in the long run, it's super duper handy. And the game engine can take that information and tell it to do things like have the feet line up with the ground that you're walking on, so you don't float. Look at this. So his feet are always touching the ground, and he can jump like way too high. Yeah, kind of cool. And actually, you saw right there. See that? His right foot is higher than his left foot. It's just adaptively changing the animation so that it's connecting to where it should be. You have to do a lot of work to set it up like that, but this wouldn't be possible if the skeleton was set up in an FK kind of manner, because it just wouldn't know how to transition the bones.
That's dope.
Yeah, super cool.
Yeah.
So that's what we'll be learning when we get there. Pain. The reason why is rigging can be a huge pain in the ass. It's just brutal. And then other times it's actually quite fun. Some people really enjoy it because it's kind of like the entryway to turning something that's static into alive, right? So once it's rigged, it has the possibility to move and animate and do everything. So it's quite cool that way. Pull targets allow elbows to be defined on IK or like joints or whatever. It basically says keep the elbow here.
Okay.
Yeah, that's about it. So if you ever see elbows flipping around or certain things getting weird, they can help. So in getting into modeling theory, essentially, if I'm going to paraphrase this, it's just working smarter, not harder, kind of thinking about it from start to finish, right? The low to high poly workflow is like super helpful and handy for getting you to like kind of think that way. Yeah, that's about it. Economic modeling, keeping it down, right? So on the left, we see the same exact thing as on the right. However, on the right, for some reason, it has way more polys. So if something's actually deforming and you need the shape to change, we can put in polys there. If not, you can just remove it, and then we would get the exact same result in this situation. Early on, we kind of want to think about doing things in complete selections and complete ideas. So the one on the left here, we basically only did the operation just on the top one, and then on the right, on the bottom, this is the operation done all the way around. So this is actually a really good example of a really nasty pull. Pull meaning, there's lots of connections going into one thing. So that pull will give you tons and tons of issues later on. Yeah, starting with the right shape. Guess I didn't get that. Changing that slide, but yeah, there's many shapes we can pick from when we start, and starting with the right one is going to help quite a lot. Yeah, and then this would be like setting up Blender. Do you guys want to do that right now, or maybe tomorrow we can open it up? Yeah, I was gonna say that sounds like a good time to end. Cool. Thanks for sticking through UV unwrapping, because that's always really hard to explain.
Yeah. All right.
Cool.
Right on.
Hey, Alex.
Yeah.
Thanks, Papa Alex.
Grandpa Fingers.
Papa Alex? I guess that's what we're calling him now. I'm down with that. I'll keep that in mind for tomorrow.
I have so many nicknames with being old. But it's good.
Yeah. You're a young dad.
I'm a hip dad. I'm a cool dad.
You're a hip dad, yes.
Young Papa Alex. We'll just add it at the front.
You're a hip dad with great hips.
Very mobile.